Law of cosines can be used in three different ways. If you notice here, if you're trying to find side length A or side length B or side length C, you would just rearrange it as necessary. Follow this formula, and all you need are two of the sides and the angle that's in between them. Or you can do it with three sides. We're going to do it with two different examples here. We're going to solve a triangle given two sides and the angle between them. You notice this one's side A and that one's side B. Therefore this must be side C, and therefore this must be angle C. So what we're given is the angle amount for C. When you look at this, in order to use these two, we need angle A or angle B. Since we have angle C, we'll be finding the side length C. So we will do C squared equals A squared plus B squared minus 2AB cosine C. So when we plug in these numbers, C squared is equal to 15 squared plus 28 squared minus 2, 15, 28, and for cosine C, we can do the approximation. Actually, I'm just going to put cosine 82 right now. We could do it in a calculator and get an approximation, but it's better if we wait until we do it all at once, or almost all at once. So right now, if you square these and add them, you get 1009. Oh, let's do C squared minus 840 times the cosine of 82 degrees. Well, the issue here to watch out for, it's a very common mistake, even though people know better, to do this subtraction, 1009 minus 840, and get, what's that, 169. And they would do 169 times cosine of 82 degrees. The only problem with that is that this is multiplication. And the order of operations says that you do this first. So if you do it correctly and you do this first, you get that C squared is equal to 892. Oops, I started writing the wrong thing, so let's change it. I'm going to transpose my numbers, but I caught myself in time. Good. So when we do the square root of both sides, C is equal to plus or minus the square root of 892. You can immediately throw away the negative because distances can never be negative. And that is approximately 30. And it doesn't say what the units are, so we'll have to use the word units. So it's approximately 30 units for side length C. To solve a triangle, we would need to find the other parts of it as well. So now we can say that this is 30 units. We also, I'll circle that 30. Now we also need to find these two angles. So we have enough information with one side length and the angle across from it, and either one of these to do sine C over C equals, doesn't matter which one we use here, I think I'll use sine A over the amount A. Because we, and what happens many times with this is you use the law of cosines to get something, and then you use the law of sines to get the rest of it, or part of it, because it's actually easier to do these calculations for most part. So we have the sine of 82 divided by 30 equals the sine of A, which we don't know yet, over 15. So when you cross multiply, we're going to have sine of A, well, we just multiply 15 to both sides. You get 15 sine 82 over 30. Then that means that sine minus 1 of all that will be equal to, or is approximately equal to, whatever A is. So now we can find A by putting that into the calculator, and you get 29.7. You could round that to 30 degrees. It's close enough that you could just say 30, or you could say 29.7. I'm going to leave it with 29.7. 30 would also have been okay too. 30, okay. So up here, this is side length A, so across from it would be angle A, and we'll put 29.7 degrees. Now we can do 180 minus the 82 for angle C minus 29.7 for angle A, and that tells us that angle B is 88.3 degrees. So we're going to put 88.3 degrees here. So we have solved this triangle by finding all three missing parts. We were given 3 and found the other 3. Now let's use this example for when we have 3 sides. We are going to solve the triangle given all this. Okay. Because we have all 3 sides, actually it means we can use any one of these we want. It just doesn't matter which one. We can use the a squared in these, the b squared in these, the c squared in these, because we have a, b, and c. We will do all of these and we will solve for the angle, whichever one we want. So since I have the a1 on top, might as well just use that. So I'm going to use that a squared is equal to b squared plus c squared minus 2bc cosine. Sometimes I'd start writing sine, I have to catch myself, and that it's the cosine of a. So now we'll plug these things in here. That's 16 squared equals 20 squared plus 22 squared minus 2, 20, 22 cosine a. So we get 256 is equal to 884 minus 880 cosine a. Again, avoid the temptation to do the subtraction. You have to multiply first, which actually means then subtract this from both sides. So we're going to subtract 884 from both sides. And we have negative 628 equals negative 880 cosine a. So since both sides are negative, when you divide, and what we'll do is we'll divide by that negative 880, the negative will go away. And 628 over 880. So what we have here is that the cosine of A is equal to that. Therefore, cosine minus 1 of 628 over 880 is going to equal angle A. And I'm going to approximate it because it comes to just about 44.5 degrees. Okay, so since we know that, if you think about it, we know side, side, and side. We know one angle, we need to find another angle. So this one was A, angle A. Let's do sine of A, which is 44.5 degrees, over length A is equal to sine B over length B, which is 20 from up here. Now we could have used C instead if we felt like it. We could have used sine C over 22 and we would still get we'd get the correct answer for angle C, and then we'd find angle B. But I'll use this one. So we'll say that sine B is equal to 20 times that, sine 44.5 degrees over 16, which means sine minus 1 of all this, 20 sine 44.5 degrees over 16, is equal to B, angle B. So when we put in the calculator, I'm going to say is approximately equal to 61.2 degrees. So what we now have is two of the angles, angle B and angle A, and if we add them up and subtract from 180, we will get angle C. So 180 minus 44.5, 180 degrees minus 445 degrees minus 61.2 degrees is going to be equal to 74.3 degrees for C. So we were given those three. Our goal was to find angle A, angle B, and angle C, which we have now done. They are approximately equal to 44.5 degrees, 61.2 degrees, and 74.3 degrees. So that's how you handle it when you have all the sides and no angles. You can still use the same formula. You're just going to have to at some point do the minus 1 function. in order to get the angle amount. And here you have to do it twice, cosine and sine. So on the last page of this, it's to analyze when to use the law of sines or the law of cosines, or it's more appropriate to say when to start with. Start with. And to some extent, it's just whatever you're able to start with. So let's take, for instance, for the law of sines, if you have an angle and its opposing side, which we sometimes call its matching side, the one across from it, side, and one other side. So what that would mean would be an angle like this, and then this side that's across from it, and one other side, either this one or this one. Now, and on here, if you had two angles and any side, I shouldn't say any side, and either opposing side, so it would be like this angle and this angle, and either this one or this one. Okay, across from that and across from that. This one wouldn't do it, because for the law of sines, you have to have at least one pair of two things. So if you had this angle and that side, it would be like these two. And then this angle would give you that. Okay. If you didn't have those two, and say it was this one, you would have an angle, and you'd have this side. Well, then you don't have any pair, and you're not able to use this. You couldn't cross multiply. You couldn't choose two of these to cross multiply with. So it would force you into using the law of cosines. So for the law of cosines, let's look at the two main possibilities, or the times when you would have to use that. So there are two main ways. You still need three things. So this would be two sides and the included angle. So it would be this side and, say, this side and then this angle, because that angle is in between those two sides. And then here, this one would be if you had all three sides, oops, let's spell that right, but no angles. Okay, so we'd have this one, and this one. Now the good thing about this is if you had this setup or this setup, it's not possible to use the law of sines, because you would have one of each of these pairs but no full pair, so you wouldn't be able to do any cross multiplying. And for these two, you would not have enough, because on these you would not have enough with either of these to do this, because you have to have the angle here that's separated, or let's see, yeah, this angle here you can't have. I'm trying to think here, because I'm wondering, could we do it with some of these? Nope, because you have to have this one across from there. Although the good thing is this one's very useful for it. So I'm trying to think that if I had that angle, yes, there's one problem. If you have the two angles here, it is not possible to use this, because you need to have at least two sides with all the places for that. If you have two sides and an angle, I think you could still use it in that case. I just haven't tried that example. But I do have to advise you, as you've seen, doing this takes a little bit more work than doing this. So if you have a chance to use the law of sine for law of sines at first, then do that. Okay, so this is one of the kinds of questions you'll often get on in trigonometry quizzes or tests. is given these possibilities, or given one of these, which is the best one to start with, and then you have to choose from them. Okay. So in the law of cosines, you're seeing what it is, how to use it when you're given two sides and the angle between, and how to do it when you're given three sides. It gives you a good deal of flexibility. So between that and the law of sines, anytime you're given at least three things, you're able to solve the triangle.